let's talk about those cases where you have more unpaired electrons than you have atoms to bond them to in a Lewis structure. This is when we're going to use multiple bonds. And so we saw in that THC molecule that it had those double lines in a few places, and that represented 4 electrons. And so sometimes atoms will share more than 2 together. They'll share 4 or they'll share 6, and those make double and triple bonds. So this 4, this will be a double bond, and you'll see it as 2 lines, and 6 will be a triple bond, and you'll see it as 3 lines. So I'm going to walk through an example to demonstrate this for CH2O. And I'm going to just go through those steps that I just showed you for Lewis dot structures. This time I'm going to incorporate a multiple bond. So I've got carbon, hydrogen, and oxygen. I've got 1 carbon, I've got 2 hydrogen, and I have 1 oxygen. I'm going to figure out the number of bonds that they're going to form first. So carbon, we do that 8 minus the 4 outer electrons. It equals 4 bonds. Hydrogen is going to be, remember, duet rule, it's weird, 2 minus 1 outer electron. So that'll be 2 bonds. Sorry, 1 bond. I can do math. And then our oxygens, they also follow the octet rule, and they each have 6 outer electrons, which will be 2 bonds. And so my carbon has the most bonds that it's going to need to form. So it's going to start in the center of my molecule. So I'll put it here. And I'm going to draw its electron dot symbol to help guide me. And so I see 4 unpaired electrons here. The next thing I'm going to add into my structure is the next atom that needs the most bonds, which is my oxygen. So I'm going to do my oxygen second. So I'm going to put in my carbon first, and I'll do my oxygen second. So I'm going to add, I just have 1 carbon. I have just 1 oxygen. I'm going to add it here. And when I'm adding it, I'm going to line it up. So it has one of our unpaired electrons lined up with one of the unpaired electrons on the carbon. And so these are going to become shared, and they're going to form a bond. All right, now I have 2 hydrogens that I can add. So I've got these 2 hydrogen atoms that I can place somewhere in here. And when I'm deciding where to do it, remember, I'm going to line it up with one of my unpaired electrons and choose that spot. If I do that, though, I've got 1, 2, 3, 4 spots I can place them. But I only have 2 atoms to place. So I can match up 2, but I'll still have 2 electrons unpaired, which means I won't be able to like satisfy that octet rule around my oxygen or my carbon, which means the structure's not done. So at this point, I'm going to say, oh, that's weird. I am going to make a multiple bond. So if I have 2 leftover electrons, I'm going to take the other 2 and have them share. So this requires taking 1 electron from each atom that are already adjacent to each other, that they're forming a bond, and contributing them into a multiple bond or a double bond. So I'm going to take 1 from oxygen and 1 from carbon to create a double bond. And I'm going to redraw this to make it nice. So now I have just 2 unpaired electrons left, and I have 2 atoms to bond them to. Perfect. So let's highlight them. These 2 are left, so I can match them up with these hydrogens here. So this one moves over here. This one moves over here. Okay. I think I have a structure. I'm going to redraw it because this looks like a mess right here. So we have a carbon. And now when I have a double bond, I'm going to draw two lines, one for each set pair of electrons. And then I have bonds to hydrogens too. Great. I need to include my lone pair still on my oxygen. Here. They're right here. And I didn't do anything with these other than leave them there and not touch them, as you should do with lone pairs. So now I can double check. My oxygen has two lone pairs. That equals 4 electrons. And it has two bonds. That also equals 4 electrons. If I add those up, that has 8 electrons. Great. My carbon has 4 bonds. That equals 8 electrons because each bond is 2 electrons and it has 0 lone pairs. So it has 8. Great. And my hydrogens have 1 bond and 0 lone pairs. So that equals 2 electrons, which is not 8, but it's 2. It's what hydrogen wants because it's small. All right, so that's a reasonable structure with a multiple bond. Let's look at let's come down and look at our THC again, and let's highlight those double bonds that we saw earlier. So here we have one here, and we have 3 here in this ring. And so if I were to blow this up then and look at the Lewis structures of it, this piece right here would look like a carbon bonded to a carbon, and this has a carbon, and it has a double bond. And so that double bond piece is right here, and it represents 4 electrons that are shared. Over here, this structure right here is interesting because it's 3. And do you notice that it's alternating double, single, double, single, double, single? We actually call that a conjugated bond system. You don't have to keep that in your head. And it looks like this. And so here, these double bonds are alternating, and it kind of makes all of these carbons equivalent. It's really interesting. And there's a lot of stability with these alternating single and double bonds. In this case, it has what we call a resonance structure. So it could shift these bonds around into another position next to it and essentially be the same. That no matter how you arrange these double bonds, as long as they alternate single, double, single, double, single, double, all of the carbons in that ring have the same number of bonds to it. They have a double bond and then 2 single bonds.